And my focus in tonight's talk is around the question of what if farmers, businesses, other non-government groups became more involved in conservation management in New Zealand, and particularly in the management of our unique biodiversity. I thought I'd start by defining what I mean by biodiversity, and I know it's a well-used term and its meaning is widely recognised, but I just wanted to make the point again, it refers to the species that are out there, to the plants, the animals, the fungi, the microbes. It refers to the genetic diversity amongst the individuals that make up each of those species, but it also refers to the communities and the ecosystems within which those species occur. So it's a very broad term, and it includes a range of different components of biodiversity, or the term includes a range of different components. In this talk, I'm going to talk primarily about our native or indigenous biodiversity, and I'll use the word biodiversity conservation to refer to our native or indigenous biodiversity. But of course, the biodiversity of New Zealand also includes all of the exotic species that have come to New Zealand in the last, 700 or 800 odd years that people have been here. But I will use the term biodiversity as a generic term to refer to indigenous biodiversity. Okay, what am I going to cover in this talk? I want to cover four major themes. I'm going to spend a reasonable amount of the first part of the talk looking at the changes that have occurred to our biodiversity in New Zealand over the period since humans came here, and then comment on what is the state of biodiversity today. I'm then going to look briefly at some of the ecological realities of the world today. I want to look at some of the current approaches that are being used to conservation management in New Zealand, and then I want to focus again for some time at the end of the talk on some of the options and alternatives for conservation management in the future. So I'll work through each of those sections and come up with a few conclusions at the very end. So in this first part of the talk, I want to look at biodiversity decline. What have been the changes in our native biodiversity in New Zealand over the period since humans first arrived here? I'm going to suggest to you that habitat loss was really important historically, but today in New Zealand, invasive species are the major driver of biodiversity change, the impact that invasive species have on our native biodiversity. I'm going to briefly comment about global change and really just try and make the point that we're still quite uncertain about its implications for native biodiversity. I'm going to make the point that flow-on effects, that the effects of one lot of drivers will have effects on other things further down the system. And I'm going to conclude that as a result, New Zealand has a disproportionately large number of threatened and extinct species. I'm also going to try and make the point that these threats are not something that occurred at some point in the past when the Māoris first arrived in New Zealand or when the Europeans first arrived in New Zealand. These threats are still playing out today, and processes of change, and particularly decline and extinction, are as prevalent, if not more prevalent today than they have been in the past. So I've just put together a very simplistic summary of some of the major factors that have influenced or driven native biodiversity downwards over the history of human settlement of New Zealand. And I'll come back and look at some of these in more detail in a few minutes. I think in the period of Polynesian settlement, the period before Europeans arrived in New Zealand, habitat loss had a major impact on native biodiversity. We lost about a third of the forest area over that period due to fire. Overexploitation was important, particularly hunting. Hunting of moa, of course, resulted in their extinction. There were invasive species, ignoring humans who of course were invasive as well, but there are other invasive species. But their impact at that stage, while some species, rats in particular, had a major impact on some birds, overall compared to the more recent period it wasn't as significant. Moving into that early European contact period, really right up until probably the middle to latter part of the last century, habitat loss continued to be a major driver of biodiversity change. Overexploitation in the sense of hunting species to extinction reduced, but invasion started to become more and more important. We also saw impacts from pollution, and we started to see potentially some flow-on effects. Small fragments of native forest started to lose species because of habitat loss that occurred earlier. Today in New Zealand, I'd suggest that habitat loss is still there, but I don't think it's a major factor, while invasive species are really the single biggest driver of change. Pollution is still out there, climate change is probably starting to have an effect, and flow-on effects are there still. In the future, I'd suggest that invasions will continue to be the major driver of biodiversity change, but we'll start to see climate change, and we'll certainly start to see flow-on effects increasingly impacting on biodiversity as we move forwards. Just look at some of those factors. This is a very well used diagram in many situations, but just trying to map the likely land cover in New Zealand before humans arrived and the land cover today. And focusing particularly on the green areas. So New Zealand was probably 3/4 forested when humans first arrived here. Over the Polynesian, the Māori settlement period, we lost about 1/3 of that forest, and then over the European settlement period, we lost another 1/3 of that forest. So we've gone from about 75% forest cover down to about 25% native forest cover. The evidence for Polynesian fire is pretty abundant. We see logs, tōtara logs here, for example, that can be radiocarbon dated and shown to have been burnt around about 600 years ago, 500, 600, maybe 700 years ago. We see charcoal, buried forest soils dating to the same period. We see the evidence in sedimentary deposits. So this is pollen deposits. Here's 1400 AD. This is from Marlborough, abundant beech pollen and then a rapid drop in beech pollen at that time, corresponding with a rapid increase in bracken and grass species that came in after those fires. And we see this is on Banks Peninsula, Mount Herbert, the back of Mount Herbert, the big Kaituna Valley Scenic Reserve there. That tree line is an induced tree line by Polynesian burning, and in fact this log was photographed on top of Mount Herbert and telling us it was previously forested right over there. The Polynesian habitat loss was almost totally by fire, and it mainly affected the eastern parts of New Zealand. Although there was also some clearance for cultivation and for other reasons in the north, but the large areas of forest loss were in the eastern areas of New Zealand. With European settlement, this is a very famous diagram that Hugh Wilson put together in one of his publications. With European settlement, we saw again rapid forest loss, but this time to provide land for farming, to provide timber for building settlements. And this is the Banks Peninsula story. 1830, still predominantly forested. By 1880, it had severely contracted, and we can see how places like the head of Akaroa Harbour and a lot of the other bays, we're seeing people are working out of those bays, clearing the forest to either to produce timber to go into Christchurch and other towns, or to clear land for agriculture and for farming. By 1920, Banks Peninsula was really down to its lowest forest cover, and there has been some recovery since then. What's really important about these two phases of forest loss, both the Polynesian phase and then in the more recent European phase, is that its impact on the forest has not been evenly distributed across New Zealand. So the lowlands have lost disproportionately far more forest and hence biodiversity than the uplands. So I mean, this is a Taranaki ring plain around Mount Taranaki, and I mean it's very obvious where the national park boundary is, and all the land lower down, further out of course, is now productive farmland. This left-hand diagram is not actually an altitudinal diagram. It's showing different land use capability classes. So land use capabilities 1, 2 and 3 are very productive land. Very good for farming. As you work your way up towards 6, 7 and 8, you're becoming less and less productive from a farming and point of view, and it just shows the proportion of each of those land use classes that still support native vegetation. So it's no surprise that in the most productive land use capability classes, we're looking at very, very low native vegetation cover. When we get up to class 7 and particularly class 8 land, which has got really very little use for productive purposes, we're seeing very, very high cover. And that reflects really the focus of European deforestation, which wasn't creating land for productive, particularly farming use. Just want to comment briefly on land cover change in the last decade or two. There is still habitat loss going on in New Zealand. The bottom right-hand diagram is a photograph I took in the Motuia Valley over near Springs Junction, probably 10, 15 years ago now, where a farmer has cleared a small stand of silver beech to expand a dairy farm. The top left-hand photograph is an interesting one and really highlights some of the dynamic natures of our landscapes. This is up in the Hawke's Bay area. This is Kānaka forest. It's been sprayed to kill the Kānaka, but it was pasture 30, 40 years ago. It's regenerated into Kānaka and it's been sprayed off again as the farmer tries to bring it back into production. But certainly, while there is still habitat loss going on today, it is a lot more localised within the landscape than it was historically. And in fact, a lot of the vegetation change we see today in landscapes, and I'll put two examples here, one from both from North Canterbury, one from Waipara with vineyards going in, and the other one a reforestation in North Canterbury. A lot of that sort of very obvious change in the landscape is almost always going from one production land use to another. So in both of those cases, the former land use was pastoral farming. So we're not seeing necessarily a change in terms of native biodiversity. We are just seeing a change in land cover. And a lot of the apparent change out there is that sort of change. But there are examples where there is still some change. But the rate is nowhere near as great as it was historically. So moving on to invasive species, I mean, look, we've got thousands of invasive species in New Zealand, so I've just put 4 examples up here just to try and illustrate some of the range. And of course, there are invertebrates, there are fungi, there are other types of species that are invasive in New Zealand having major impacts as well. I put lupins up as an example of a plant. I mean, lupins are rapidly colonising many of our riverbeds. The Waimakariri, I remember 20, 30 years ago, hardly any lupins in it at all, and now it's really filled up, and many other places are like that as well. Amongst the mammals, of course, the herbivores, the ungulates, possums, of course, as well, are all having an impact. I mean, goats are a devastating animal, and it just really appalls me how many places in New Zealand now have goats that didn't have goats not that long ago. Amongst the predators, I mean, the well-known ones are, of course, the mustelids, stoats, ferrets, weasels, rats, but of course cats as well. And this is caught up at our Cass research area, the university's Cass Mountain research area. Night camera shot just showing a cat up there. I mean, if you're up there in the daytime, you wouldn't see them, but they are certainly there, and they stand out when you start putting this sort of equipment out in the field. There are lots of other invasive species. I put a photograph of a trout in to make the point that we often forget about what's going on in our freshwater systems. And I mean, the massive decline in our native freshwater fish is driven largely by, much in New Zealand, by trout. Trout have a huge impact, particularly in the more remote areas in the East and South Island. Trout are having a massive impact on our native fisheries. So there are a whole raft of species there. From a biodiversity, a native biodiversity point of view, I mean, the impacts of invasive species are well known. They've been well documented. A look at the impacts of predators and just some general data, and then a specific case study. This is some work that was published a couple of years ago, but just looking at forest birds, so just looking at birds that occur in our native forests, looking at birds that are categorised as threatened, so things like the mohua, the yellowhead here, birds that are classified as at risk. The rifleman would be a good example there, and birds that are not threatened, things like bellbirds and grey warblers. And then looking over the period 1979 to 2004, looking at how their distribution in New Zealand changed. Did they increase, become more widely distributed? Did they stay the same, or did they decrease? And so with the threatened species, they continue to decline. 7 of the 11 species declined, 4 didn't change. Of the at-risk species, 5 of the 7 species declined, 2 didn't change. Of the non-threatened species, 3 declined, and these are not threatened species. 9 didn't change the distribution, and 4, in fact, increased. But what's really concerning is that, you know, we are still seeing, and this is only in the last 30-odd years, we're still seeing ongoing decreases in the distribution. And that's not looking at their abundance within that range, which is also decreasing. So I put the mohua up as a specific example. This map, which comes out of the State of the New Zealand Environment Report in 2007, shows the likely pre-human distribution of mohua, which is the whole of the South Island. The loss of much of that was due to habitat loss, forest loss, both with Polynesian and European clearance. But in the 1970s, it was still present in the Sound, through Kahurangi, down through the Buller into the Lake Sumner area, then right down in the southwest and through to the Catlins. And you can see much of that's been lost, again, just over this sort of time period here. And this reduction down to these core areas in the southwest here primarily, there's still a couple of populations in Canterbury as well, is mainly due, almost exclusively due to the impacts of invasive species. Moving on, looking at herbivores. Herbivores, deer, goats, the ranger herbivores, possums of course as well, are all having a major impact on our forests and our grasslands. And I just use the example of a plant called Griselinea or broadleaf. It's a common small tree in New Zealand. It's this glossy large leaf thing here. And when you go through beech forests, through much of the northern South Island, through much of the North Island ranges, you'll only ever see broadleaf foliage sort of at above head height, or occasionally you'll see the odd seedling, but you're not seeing any broadleaf plants of middle size. They're just not there. And the reason they're not there is they're being browsed out by ungulates, by goats and by deer. This is some data from the Kaimanawas. It shows for at the top here, red beech and silver beech, showing the size, the numbers of trees across from small seedlings to bigger and bigger trees. You work from left to right, and there's a range of tree sizes there. But for both kamahi on the left here and for broadleaf grisilinea, there is a major gap in their abundance. Lots of seedlings, but nothing's getting through and then becoming trees. There's lots of adult trees, but there's no recruitment going on for those species. And those species are going to gradually disappear from those forests because of the impacts of ungulates. In terms of plant invaders, there are numerous plant invaders. I'll just put a few examples in here. Chilean flame creeper are climbing a vine that is invading more and more of our forest remnants. Floating sweetgrass and lots of small ponds, ephemeral tarns, places like that. Obviously, Mousehare hawkweed in the bottom there in the Mackenzie Basin, covering huge areas of our short tussock grasslands, or what were short tussock grasslands, and wild and conifers invading into ultramafic vegetation in the Nelson area, naturally open habitat that are being invaded by, in that case there, Douglas fir and Pinus contorta, lodgepole pine. Just want to look at one example again, looking at the impacts of those invasive species in terms of biodiversity. And this comes out of work that one of my students did, and we've done other work as well on some of these species, where we are finding that there is a whole guild, a whole group of eastern South Island shrubs, lianes and small trees that are basically failing to regenerate. They're still there, there's still quite a few of them in the wild, and they include our New Zealand brooms. And I put a photograph here of one of the brooms, it's the genus Carmichelia. They include some of the tree daisies, they include a species of hebe, they include a range of things, but they're all failing to regenerate, and it seems to be a very general pattern right across. And these are just the nationally endangered or the nationally threatened species, so the critically endangered, endangered and vulnerable species. These are species that are facing quite an imminent threat of extinction, and there's another group of species that are declining that are in the same category. And that's purely because of competition with introduced grasses, by and large, for regeneration. What's happening is that these plants, they drop their seeds, but the sites they regenerate in are now occupied by invasive grasses, and the grasses are simply stopping them grow. And so some work, this is from Ingrid's work, my PhD student's work, looking at a range of these native brooms here, several different species, comparing the growth of seedlings grown with grass and without grass. And I mean, just the effect is abundantly clear. These grasses are directly competing and driving these species towards extinction. They'll hang around for a long time because they live for decades or even longer, but at some point, without recruitment, they're going to disappear from the environment. And this is an example here of two of these species. On the left is a little tree daisy. It was only recently described in the last decade. It occurs around McLean's Island and down towards the Rakaia River. And you can see the grass sward that's trying to grow in here. And I should just point out, some of you might know Brian Malloy. Brian's been a real mentor to me over the years. He unfortunately couldn't be with us tonight, but much of my thinking has been very much influenced by him. He's been a real major player of a lot of these issues. This is Leona hebe, Leona hebe cupriosoides. It's in the hebe group, and it's another species a little seedling trying to grow here in a dense sward of brown top, and it's really struggling and finding that a very difficult environment to get away in. Just moving on and just touching on climate change, and I'm not going to dwell on climate change. We don't really understand what the potential effects of climate change might be. I mean, this is the Hawkton Range on the Canterbury-Otago border. I mean, people have suggested that plants that might live in these isolated ranges, particularly in the alpine zone, might get forced out of there as temperatures increase. We don't really know. Probably more concerning are changes in extreme events, changes in other factors. So, for example, a change in the snow duration on a range like that could have a big influence on the alpine vegetation. If we have less snow, there's more freeze-thaw going on. The snow's not protecting the plants that are underneath it, and we could see quite major changes. The same with storm events, flood events, wind events, all those sorts of things as well will all have an impact on biodiversity. But we just don't know what those impacts are going to be. It's too early. What does concern me, though, is the fact that it's not just those primary factors that are really playing a key role. It's also the changes that occur as a consequence of those primary factors, invasions, or habitat loss, that are having flow-on or ongoing effects and will really impact on biodiversity. I just put two examples in here. This is looking down the side of an exclosure plot. So this is an area in the forest that's been fenced off. and it's a bit hard to judge the scale here. It's actually been fenced up to about 2 metres height so that deer and goats can't get into this plot either. This is up an isolated hill in southern Marlborough. So on the right-hand side of the fence, we're inside the exclosure plot where the ungulates can't get. On the left-hand side, we're in the outside where they can get. And the difference is striking. It's obvious, very, very obvious. And this is this griselinia or broadleaf here, showing very healthy regeneration where the deer and goats can't get. But there's been some interesting work done in recent years looking at what might be some of the flow-on effects of herbivory in these systems in terms of other parts of the system. This is work by David Wardle and colleagues out at Landcare Research, where they looked at some of the other parts of the system and how it was responding to that. So just explain this diagram here. So we've got, again, let's refer to this first of all, outside the exclosure, inside the exclosure. And over here we've got a whole raft of different groups of organisms and one or two other factors as well. Just focus on the red boxes. The top red box shows the biomass of vegetation, autotrophs of plants, the biomass of vegetation in the browse layer compared to outside. When the bars here are on the right-hand side of the central zero line, it means there's more biomass or more abundance of, in that case, the plants inside the exclosure plot than outside. And we can see that in the photograph really obviously. But what I wanted to focus on was this bottom group here, which are a whole lot of the small creatures, the sorts of things in the petri dish here, that live in the litter layer. And these guys play a really important role in decomposing litter, decomposing organic matter, and then releasing nutrients and allowing the whole cycling of nutrients. And what's really interesting and really concerning is that all of these guys in the red area anyway, all have higher abundance on the inside and significantly lower abundance on the outside. And so they are far less common, which is suggesting we're going to see down the time in the future, we're going to see changes in decomposition and then changes in nutrient cycling. We don't know what the consequences of those changes will be. Another example, and Dave Kelly's here, so I'll acknowledge this is from some of his work, looking at the role of mutualists, both pollination mutualists and dispersal mutualists in our forests. I just put up a dispersal example here. And this has been a story that's been discussed a bit for a few years now. But the idea that we have a forest flora that has a lot of trees that are dispersed by birds. They've got fleshy fruit. There's a tawa fruit here. There's only a couple of ripe tawa here. The rest of them are unripe. But we've got a lot of trees that have fleshy fruit. Not the beeches, but a lot of our other trees have fleshy fruit. And they require birds to disperse them. And for a long time, people were thinking that the loss of so many birds from our forests was going to be a really serious obstacle for the regeneration of some of these trees. And what's interesting, this diagram at the bottom here, just looking at northern North Island, southern North Island, western South Island, eastern South Island, this is different sized fruit. So fruit that's got a diameter greater than 14 millimetres, 10 to 14, 7 to 10, 0 to 7, and then fruit that's got dry fruit like beech. And tawa sits up in this larger area here. But what's interesting is that certainly in the northern North Island, these larger fruited species are making up a quarter to a third of all of the biomass in those forests. Now, Kererua is still there. We know that tui can disperse some of these fruit as well, but certainly the range of dispersers that were there historically, kokako, are still around, but are very, very rare now because the moa have gone. A lot of these other dispersers are very rare or absent, and even Kererua and tui aren't necessarily as common as they were before, and we don't know what the consequences of that will be. I mean, it may well be there's still sufficient dispersal going on, but it's important to recognise that there are these potential flow-on effects that may well play out in the future in terms of what's going on in our flora and fauna. So just to finish off talking about change in biodiversity, I just wanted to briefly just give you a feel for the status of biodiversity today. Just a few groups here: vascular plants, land birds, other birds, reptiles and freshwater fish. Numbers of species extinct that are considered directly threatened of extinction, at risk. It's a lower category, and then not threatened. The point to make is there are an awful lot of species that are threatened or at risk. Now, I put two plant examples. I'm a botanist, so I put two plant examples down. The Castle Hill buttercup is a nationally critical species, really threatened by invasive plants, and one of our mistletoes, which is threatened by a range of factors. It's an at-risk species. It's not actually threatened at the moment, but it's certainly declining. But we have a large number of species that are threatened of extinction, and these threats aren't going away. These species are threatened today. It's not that they were threatened 100 or 200 years ago. They are still threatened today, and many of these are still declining. And just make one final point around the status of our biodiversity today, is that extinction is not a simple process. Extinction is a complex process, and it's often not just one factor. Sure, when a rat invades an island and decimates the fauna, that's an obvious cause and effect, but more often than not, extinction is more complicated than that. And this is a mistletoe, one of our more recent extinctions in New Zealand. It was last recorded in the wild in 1954. It was a northern North Island species. It parasitised a ranger tree species. This is a site where it was last recorded in the Waikato. Hasn't been found since, despite repeated looking, but its extinction was probably a combination of factors. Habitat loss certainly played a key role. Loss of the pollinators and dispersers. It's a bird pollinator. We think it was probably a bird pollinated species. It certainly required birds to disperse its seed. And it was, I hate to admit it, but it was over-collected by early botanists, particularly on places like Waiheke Island, where there are multiple collections by the same person from the same site. But all of these factors would have played a role in its demise and extinction. Okay, so another quick sip of water. So I want to just touch on briefly now some of the ecological realities of the modern world. And it's important to think about these when we think about how can we move forwards with conservation. I mean, these are pretty self-evident things. The global population continues to grow, and there's a continual demand for a better standard of living. And there is a rapidly growing middle class in countries like India and China that want to have what they regard as luxury goods, things like dairy products and meat products, leather, a whole raft of stuff, things we take for granted. They have the money now to be able to buy those and are increasingly demanding all of those things and everything else, TVs and all that other stuff as well. We know that global environmental change has been very, very rapid over the last century, and particularly over the last half century. And some people are now referring to the modern period as a distinct geological epoch called the Anthropocene. And because of these factors and because of particularly the global environmental changes, we are now having to deal with what we refer to as novel ecosystems. So I'll just show a couple of examples of these things. So global population increase, everyone's familiar with that. We're sitting about here at the moment. We're not quite sure where it's going to go, but people are certainly talking about 9 billion people by 2030 to 2050. There's still a lot of debate about the exact number, but something like that. And with that increase, clearly there are lots of people out there. They want resources, they want food, they want a whole raft of resources, and it's putting a huge pressure. We want more and more cities, big cities, massive cities, huge demands for energy, huge demands for water. That has flow-on effects for biodiversity. Huge demand for food. I mean, this is obviously rice, but equally the meat and dairy products we produce in New Zealand. And of course, huge demand for natural resources and iron ore mine in Australia here. Massive demand for these resources. So all of those things are playing out and having an effect on biodiversity in the world today. And this is why people have used this concept of the Anthropocene as an idea that perhaps the world is really quite different now. The map just shows an indication of our footprint. Aeroplane routes, the white lines, shipping routes, the blue lines, roading networks, the green lines, and just showing how dominant our footprint is on the planet. And the bottom diagram here illustrates sort of change in a whole lot of different indices that measure our impact on the environment. Just a subset of them here: population, atmospheric chemistry, water use, tropical forest area, area of domesticated land, numbers of McDonald's restaurants. All of these things are zooming upwards, and it's been this sort of thing here that people are saying we're really entering into a very different world now, and it's going to present some real challenges for biodiversity conservation. One of the manifestations of all the changes that are going on, and it's been an emerging concept in ecology over the last decade, has been the idea of novel ecosystems. And I think a lot of ecologists are now recognising that throughout the world we're increasingly facing ecosystems that are different to what they were like historically. They're different in terms of the species that occur within them. They're different in terms of the processes that occur. And we're now looking at systems where native species and exotic species are occurring together, and we're looking at systems in which different disturbance regimes, different influences are playing out, whether it's nutrient cycling, in terms of fertilisers going on, whether it's hydrological cycling. We're dealing with a different world in which our native species are occurring. This is Banks Peninsula, obviously. So some examples here, Kētaru are now utilising, I wouldn't necessarily say relying on, but certainly utilising exotic trees more and more, tree lucerne in this case here, a food source, cherries and plums in orchards. Oyster catchers and stilts here on irrigated farmland. They're feeding there. We're finding that species are occurring in combinations and situations that are quite novel and quite unique. A couple more examples. Up in the Nelson, Marlborough area, we're looking at, this is Lake Chalice up behind in the Richmond Range, we're looking at mixed exotic conifer beech forests. And they're not going to go away. They're going to be there for a long time in the future. And it's pretty hard to find a New Zealand forest that hasn't got a bird like a chaffinch in it now, or a blackbird. I mean, really some of our most remote forests will find these species in them. So when we come to looking about how we manage biodiversity, and how we manage our key native species, we've got to think or recognise that it's going to be within contexts that are quite different to what we've had historically before people arrived in New Zealand. So I want to now just briefly review and reflect on sort of current approaches to conservation management. And I think we've got a strong central government focus on conservation management. We've got a single government agency, the Department of Conservation, and relatively speaking, compared to some other countries, little involvement of other groups. But DOC staff are world leaders in conservation management. They are recognised throughout the world as being outstanding experts on threatened species management, on animal pest control, and a range of other areas as well. But as we all know, funding is insufficient, or appears to be insufficient, to address biodiversity decline. Let's go through each of these again. Just to, really, I don't want to labour the point because it's well recognised, and I think the expertise of DOC staff and the Wildlife Service before them is internationally recognised. I mean, Don Norton with a kakapo there, obviously, our work on offshore islands and with threatened species, our work on the mainland with pest control, and one of the new self-resetting traps that DOC are working on developing for stoat control. I mean, this stuff is world-class, and it really is setting the way for others. Some really novel work out of the Urweras recently, where they are, kakabeek's one of our most endangered plants, actually two species of kakabeek, but both of them are they're both critically endangered, being devastated by ungulates, by deer and goats, but DOC and other workers have developed a novel way of using a shotgun to fire seeds up onto cliffs where those animals can't get to re-establish these plants. I mean, there's some really, groundbreaking work going on. I also want to mention the Forest Service as well, which gets a lot of flack, and used to get a lot of flack, it doesn't occur now, of course, but even the Forest Service did some really exciting stuff, and particularly wanted to emphasise their work on ecological areas, and particularly in the Bulla Westland area and in the Waikato. The Forest Service went about protecting a representative range of forest ecosystems. This is a Nokawa ecological area up just north of Denniston on the west coast. It's got an outstanding sequence of podocarp forests, mixed podocarp beech forests, and up into beech forests on the Glasgow range. I mean, it's an outstanding area. It could have been harvested, and they were set aside in these ecological areas to be representative examples for the future. And I mean, that was at its time pioneering worldwide, this sort of approach towards reserve design. So there's some really exciting stuff going on, and some really, really important contributions made to biodiversity conservation. But is current biodiversity conservation funding sufficient? This is the graph for the amount of money. This is not. This is the amount of vote conservation that goes to natural heritage. So I've taken recreation out. I've taken those other parts of vote conservation out. So this is just the natural heritage part of it. And so the bottom line is the actual dollars. The top line is CPI corrected, so it's in today's dollar terms, effectively. And it shows we had about a 30% increase in spending by central government on natural heritage conservation through until 3 or 4 years ago, and then it's plateaued and declined since then. But I think the point I wanted to make is that has that increase been sufficient to address biodiversity decline? And I think all of the people who have looked at this question have agreed that it has not been sufficient. It is not stopping biodiversity decline, and there are a wide range of indicators. I mean, the number of nationally threatened plants has increased from just over 100 in 1999 to well over 200 now. Some of that's because we know more about what's out there, but a lot of it's because things are increasingly becoming threatened. Only 12% of public conservation land receives sustained possum control, so 88% is getting no sustained possum control, so possums continue to impact on it. In a review of the New Zealand Biodiversity Strategy, Bruce Clarkson and Ren Green concluded that 77% of threatened species don't receive any targeted recovery work. We know that even where control goes on, impacts can still be widespread. This photographs in Silver Beech Forest on the Glasgow range, which gets annual goat control, but the forest still completely lacks any of its palatable understory layer, and the goats are still there. You see the droppings, you see the animals around. So even with the control we're doing now, often it's not enough to address the issue. And the final point I want to make to really build on that is that because of all of that and because of the lack of funding, the department is now developing this optimised ecosystem management system, which is effectively identifying parcels of New Zealand that will get ongoing habitat and species management and other areas that won't. And this system is still developing, and this probably isn't the final version, but it shows sort of the approach that's being taken now. And basically, we're picking winners and losers for New Zealand biodiversity. So with all of that, what I really want to focus on, and I'm just over half an hour through the talk, I want to really look at, well, where might we go in the future? And this is trying to look forward into where we might end up. And what I want to suggest to you is that as we think about where we want to go in the future, we need to be really clear about what do we want for New Zealand biodiversity. What sort of future do we want for New Zealand biodiversity? I believe it's really important that while people were certainly part of the problem, we also need to recognise that people must be part of the solution. And then I'm going to go on and just consider some additional approaches to conservation that might complement our existing approaches, that might add value and perhaps help us to address the declines that are out there. So I want to go through and look at each of these. I'm going to spend quite a bit of time at the end talking about the potential role of farmers and what they can do with biodiversity conservation. I put this photograph up quite deliberately to try and make the point that we do face the risk that we'll have some areas of New Zealand, this is Maungatautari, the mainland island in the Waikato, where there's intensive management going on. We've got a predator-proof fence around a 3,000 odd hectare reserve there, where biodiversity flourishes. There's going to be a lot of areas where there's no biodiversity at all. And I mean, I think that's a pretty sobering picture for the future. And I think if we end up taking that model there, we're going to have large areas in New Zealand where there are still native bush, but the forests are just empty. There just aren't the birds there. There aren't the other species there. A lot of the palatable species have gone. And that's a real concern. And I guess my question to you is that what we want, or do we want to try and address both the intensively managed areas, but try and also address these areas here? And what about our primary production landscapes? And I mean, Banks Peninsula is obviously not an intensively used area. It's not the Canterbury Plains, but it does, in my mind, highlight, this is Holmes Bay, draining into Pigeon Bay. It does highlight the sorts of landscapes that might be good for biodiversity and for production. There is room to have both in the same landscape. So I think, in my mind, there are a few sort of general principles that we need to keep in the back of our mind when we think about how we might go forward. As I said before, I think, yes, people are part of the problem, but they also need to be part of the solution. I mean, at the end of the day, you know, if we're going to spend government money, let alone private money on conservation, we have to have people on board. It's what people want that will dictate where the money goes. But people can be even more actively involved in that, not just about providing the money, but actually out there. And I think we need to get greater buy-in of people. I believe very strongly that one size does not fit all. We need a range of approaches to conservation. We need to look at a whole lot of different ways of trying to get this outcome of sustaining Indigenous biodiversity across all of New Zealand. And I think another thing we need to recognise and be really aware of is that you can't be green if you're in the red. I mean, at the end of the day, you know, health, welfare, education, those things all stack up higher in the public's mind than conservation. We've got to have a viable economy to be able to have good conservation management. And that works whether you're talking about the nation, whether you're talking about a company, or whether you're talking about a landowner, a farmer, for example. No one can afford conservation if they're not financially viable. So we've got to find ways that we make those two things stack up. And I believe this really requires us to rethink the way we view conservation. We need to think about some of our approaches towards people and the environment, towards the way we go about doing conservation. We do tend to have a fairly dualistic approach in New Zealand. It's either conservation or it's production. And I think we need to move away from that either or the other to more of a one and the other. So people and nature, private business and public and government working together in investment and management, Indigenous and exotic. It's not saying that we should manage stoats to sustain them. That's of course not what we're trying to do, but we've got to recognise that exotic species are part of New Zealand, and in some cases they can be useful, in other cases they are obviously very problematic, but it's Indigenous and exotic. Regulation and voluntary incentives, getting both of them out there. Protection and development, we need both of those. So what I want to do now is to look at some examples of just some possible approaches that I think we should be talking about more, thinking about more, that might complement our existing conservation management. I think we need to become more efficient in using the funding we have. Clearly we don't have enough money, and if we can become more efficient in how we use that money, then it will go a lot further. And this is some work, this is some slides from Graham Nugent at Landcare Research, which is just the 2 slides, just to highlight some of their work with trying to get more efficient toxin delivery systems. So looking at the 1080 question, the traditional way 1080 is spread is you fly an aircraft, a helicopter usually over an area, and you get an even coverage of 1080 pellets on the ground. And what they've been doing is they've been looking at the potential of putting out clusters of pellets. So here's a cluster going out of the helicopter now, just a small group of pellets. They land in the forest, maybe forming a cluster about 5 metres by 10 metres, all the pellets within that area, and it might be 50 or 100 metres to the next cluster. And they're looking to see how that works in terms of the success of poison control. And what they're finding is that by using the clusters, of course, you're going from the traditional 1080 control, you're looking at putting 2 to 3 kilograms of 1080 per hectare on. By putting clusters out, you're only putting out 0.2, 0.25 kilograms per hectare. So it's a huge reduction in the amount of chemical going in the environment. But what's really exciting from this research, this is looking at just one of their trials, looking at the reduction in catches of possums and rats. And this is the broadcast, the cluster, and there is no significant difference between either broadcast spreading 1080 or putting it in small clusters. And that's suggesting that we can do it for a lot. We can be a lot more clever about how we use our money, and they're suggesting a 70% reduction in cost per hectare for 1080 control. And that's got to be good for biodiversity, because it means we can, of course, cover a much larger area for the same amount of money. And there are a raft of other new technologies out there that also offer us a chance to be a lot more efficient. I think there are some alternative models for how we might distribute government biodiversity funding, and I was recently over in Australia. This is up in the Kimberley in the north of Australia, and I visited a large wildlife sanctuary run by a group called Australian Wildlife Conservancy, and they're doing a raft of work. They've got sanctuaries all around Australia, and particularly in the north, but doing threatened species work, doing habitat management work, a lot of fire work, obviously it's important in Australia, controlling invasive species, cattle in this case here. But what interested me is they manage 3 million hectares, so that's just about a third, or a little bit over a third of the New Zealand public conservation estate. But they only spend 10% of their budget on administration. 90% of their budget goes directly into these properties in the field here and on the ground management. And the reality is a government department just can't do that because of the overheads we have. So I mean, there are potentially some other models up there, and this is a very controversial diagram, and I accept that, but maybe there are other ways we can spend conservation money and to get better results for biodiversity. Maybe we need to look at a range of delivery agencies, of which DOC would certainly be one, that are spending folk conservation money. Maybe we need to have a discussion about that and think about how we can get a better return for the dollars we have. Not-for-profits, Australian Wildlife Conservancy is a not-for-profit. Maybe they've got a role to play in New Zealand as well. Another issue I want to touch on is the role of the private sector, of industry, and how we might be able to look for win-win outcomes for biodiversity and for development. This is the Oceana gold mine at Reefton. And I mean, these things are out there, they're occurring, and they're going to continue to occur, and they are from time to time going to impact on biodiversity. So can we work with those sorts of projects to get good outcomes for biodiversity? And this is the area of biodiversity offsets, the idea that we can get a trade-off in a sense between an impact and biodiversity work elsewhere that will compensate for that impact and as a result yield a better situation for biodiversity. People talk about 3 different types of biodiversity offset. Averted risk offsets, and this is a photograph of part of Stockton Plateau up to Mount William in the distance there, which could be an example of an averted risk offset. So if miners like Solid Energy and Bathurst were to do a genuine biodiversity offset here, it would involve saying we will never mine these areas through here, and that would be an averted risk offset. It's removing the risk of any future mining. A restoration offset, planting up after disturbance, and we talk about enhancement offsets where we go in and take a degraded site, a forest that's been degraded by ungulates, and we enhance the condition, bring back the native biodiversity in that area. And this is a commonly used diagram to explain how offsets work, the idea that when a development proposal first comes up, there's a primary impact. People are developers should, first of all, be trying to avoid their impact, which reduces it. They should try and mitigate. So that might be reducing the footprint of a development, mitigating their impact, so it might be having a narrower road than a wider road, doing some restoration, but still leaving some form of impact. And that's where the biodiversity offset either matches that or in fact exceeds that, the idea to get a better outcome for biodiversity at the end of the day. I think there are limitations and challenges of using biodiversity offsets. How do you quantify what the impact is? How do you quantify what the gain is? How can you provide certainties over outcomes? How can you ensure that the outcomes are actually additional to what's going on now? And there will be limitations to what can be offset. There'll be some sites where the species or the ecosystems are so critically endangered, are so limited in extent that no offset's possible. But there'll be a range of other sites where offsetting is certainly a strong possibility. But again, just to make the point that there will be some sites, and this is one example where I think it's not possible to offset because these coal measure systems are so rare, they're confined to one area. And there, I think we need to think very hard about what we're doing. Another thing I want to suggest is that we consider alternative conservation models. And this example comes from North America. I thought it was a really innovative example. It's out of Montana in the west. And these are prairie grasslands that are grazed. And the Nature Conservancy, which is a big US NGO, purchased a 24,000 hectare ranch, and what they basically do is they say to adjacent ranchers, you can graze on our ranch if you do certain things on your property that are good for conservation. And as a result of that, we're looking at 120,000 hectares getting direct conservation actions on the adjacent area around it. Things like not converting the prairie to cropland, specific habitat protection for things like prairie dogs and sage grouse, and weed management. And what's really neat is that is actually generating an even wider halo around it as farmers start talking to their neighbours and uptake continues. So this is Matador Ranch here. The colours refer to different land types, but this is the Matador Ranch. This is their primary area where they're getting benefits from, but they're starting to pick up benefits in a wider area that has a similar type of prairie vegetation. And that's a model that'd be really neat to think about in New Zealand. Maybe there's room for that sort of model. So the prairie dog, the black-footed ferret that is dependent on the prairie dog, sage grouse, and of course the conversion there to other land uses that aren't good for biodiversity, obviously. So I want to finish off by talking about farmers and how we can work better with farmers. It's become a real interest of mine in the last decade, and I think it's a really important issue because at the end of the day, 2/3 of New Zealand is not public conservation land. 2/3 of New Zealand is used primarily for farming or plantation forestry. This photograph is taken in the northern Hawke's Bay, totara, mixed podocarp forest in the foreground there, scattered totara on the hill slope, kānaka in the background, but also obviously pastoral production. I think farmers, foresters, other landowners are already doing a lot of positive conservation work, and I just want to highlight some of the things they're doing. And there's some really exciting stuff going on out there in New Zealand today. And I'll go through and look quickly at examples of each of these. A lot of farmers are fencing land off. This is up in the Rakaia, where the farmer has developed some of the degraded tussock grassland, but he's also, he and she have also, the couple have fenced off areas as well. And they've done that of their own volition. They just felt it was important to fence out some areas while they developed other areas. And of course we see numerous examples of this. So here's a forest remnant in Northland that's been fenced off to keep the animals out of the forest remnant while grazing still goes on outside. And this is really, really important because we know that well, first of all, small remnants face real issues with all sorts of change, but then when you add grazing animals on top of that, they really decline rapidly. And so this is an example, this is a grazed remnant here up behind Oxford. And you can see the nature of the remnant. I mean, well, you can look basically right through it just about. But a number of consequences come from that. So this is some data from a study comparing grazed and ungrazed forest in the Waikato. And what's really interesting is that the ungrazed forest is in black, the grazed forest is in grey, so emergent trees, canopy, subcanopy, understory and ground layer. And what's interesting is that there is marked dieback of emergent trees. Emergent trees, the big tall ones, are really susceptible to animals walking over their roots. It really affects them. They get exposed on the edges of remnants and a lot of mortality there. But equally, which is obvious in the photograph here, in this study is the understory. Huge change in the understory. And the palatable layer where the cattle and sheep are browsing the vegetation. Many farmers, not only are they fencing off their remnants, but they're also putting covenants on their remnants. Covenants, particularly with the Queen Elizabeth II National Trust, but also with other organisations that are providing a degree of certainty into the future for their management. So when they sell the property, a future landowner is bound by that covenant because it's on the title of the property. This is the Kaikatea Forest remnant in the Waikato. And just looking at the distribution of QE2 covenants around New Zealand, I mean, what's really neat about QE2 covenants is an awful lot of them, over 4,000 of them around the country, but they're mainly in the lowlands, the areas where public conservation land isn't, the areas where the loss of biodiversity has been greatest, the area where the pressures are still really, really high, and particularly in the North Island. I mean, it's quite exciting when you see the sort of spread there and down the South Island. Most covenants are small. I mean, the average size is only 30 hectares, although some are quite large. And this one in the photograph here is a place called 16 Mile Creek. It's up the head of the Shotover River, and it's several hundreds of hectares, but most of them are quite small, like in the previous photograph. A lot of landowners off their own back, sometimes with support from organisations like councils, are controlling weeds on their properties. And a lot of that weed control is being done purely because of the impacts on biodiversity. And this particular farmer here, this is in the Mackenzie Basin, has used his own money. He was actually able to generate some income by selling some of the logs from the trees here. They recognised he had a major wild and conifer problem. It was having a huge down valley impact. They were getting up into the alpine zone as well as down country further. And he's got a contractor to remove the big trees. They were felled, some of the timber was taken out, which then helped to pay for ongoing spraying, and now there's ongoing work to tidy up the remaining trees. But this is recognising that if he didn't get rid of the seed source, he was going to have a problem for the next, well, forever. It was going to become a huge problem. And I mean, those sorts of initiatives, you'll see them widely across New Zealand, whether it's blackberry, whether it's, you know, whatever weed, but lots of farmers are out there getting rid of these weeds. And of course, lots of farmers are doing pest control, all sorts of pest control. And that's a very common thing in rural New Zealand, sometimes for a production benefit, but equally because they don't like having possums or stoats or whatever affecting their bush remnants and other pieces of natural habitat. Many farmers are doing restoration plantings, and these are all examples of restoration plantings that have been done without any legal requirement for them. So they weren't done because the farmer did something else and was required to do a restoration. They were simply done because the farmer wanted to do them. And I mean, these are from Hawke's Bay in the top left, Canterbury Plains top right, Otago the bottom left, and Northland in the bottom right there. I particularly like this one here. I had my students up here on Sunday. It's a property out near Leaston. And I mean, you know, that stream is just incredible. You know, we've got a vegetated, native vegetated corridor down that stream. And I think that's really exciting to see that. And there's a lot of those initiatives. And there are lots of community groups doing it as well, and other groups also. But farmers are also out there doing it. These are all examples of farmer-driven initiatives, not community group initiatives. And some farmers even just plant native plants because they like them. You know, a shelter belt on the Canterbury, well, not a shelter belt, but a fence line on the Canterbury Plains. I mean, it's just lovely to see that in the middle of our most developed, our most biodiverse, poor landscape in a sense. We've got a range of native species along this fence line. There are many others like that as well. There's a lot of discussion at the moment and controversy about the clearance of tussocks or the clearance of shrubland, but some farmers are deliberately choosing not to do that because they see benefits from retaining it. Again, with my students on the weekend, on the other day on the weekend, we visited this property here in North Canterbury. There has been some clearance, but he's also leaving some areas behind in Matagari because he sees benefits from the Matagari. That Matagari provides a number of benefits for him, and he also recognises from an economic point of view, but he also recognises that there are benefits for biodiversity by retaining that. And just some of those examples, two photographs of sheep, ewes about to lamb, sheltering out a nor'west storm, either behind, in the bottom here, red tussocks providing shelter, or in the top there, behind Matagari. And so there can be win-wins here for farmers and for biodiversity. And it's interesting, just go back one slide, on this property here, he's got one of the northernmost records of a threatened shrub called Olearia fimbriata, and it's in that sort of Matagari shrubland. So if it had been cleared, that shrub would have gone, but he recognises the value of it and wants to hang on to it. In both these cases here, the wind's blowing from right to left. It was a howling nor'wester that day, and it's quite interesting. The sheep aren't silly, they know where the shelter is, but that certainly improves lambing success and calving and fawning as well for deer farms. There are lots of other exciting initiatives out there. I just want to mention this one from one of the PhD students in biological sciences here, who was looking at the role of falcons as a natural pest control agent in vineyards in Marlborough. This project involved reintroducing falcons back into the Wairau Valley there, into the vineyards of the Wairau, and then letting the falcons act as natural biological control agents to stop the small birds that were pecking and removing the grapes. This is a Sauvignon Blanc here, and here's some of the data here. So the overall, we went from about 13-14% crop damage without falcons to maybe 7% with falcons, particularly in terms of grape removal, but also in terms of grape pecking, and that example shows grape pecking there. So again, it's being done from obviously from an economic perspective, but it's again also a biodiversity initiative, and we now have falcons back in that environment, which I think is an incredible outcome. Some farmers, not very many, are also looking at working with agencies like DOC in terms of bringing back threatened species. And this is a property down behind Wanaka where they've been working on trying to bring weka back again, taking weka off the islands in Lake Wanaka and Lake Wakatipu and holding them initially in acclimatisation pens and then letting them out onto the farm and trying to bring them back into the wild. And again, there's no compelling to do this. It's just an initiative that the farmers entered into, the landowners entered into with DOC to try and do this. And it's worth making the point that while farmers do lots of stuff on their own, they also work a lot with groups, whether it be local community groups, NGOs or whatever. Farmers are out there and they're interacting with those groups as well. This is Harts Creek, again, just up from Lake Ellesmere, Te Wahora, where we're looking at a local water care group restoration program. But just want to acknowledge that groups like the New Zealand Landcare Trust and locally the Banks Peninsula Conservation Trust are doing a huge amount with landowners and with other individuals out there in New Zealand to try and get really good outcomes for biodiversity. So really just trying to bring things to a conclusion, and I'm going to be pretty close to the hour, I think. I want to just sort of make some more general sort of concluding comments. Why do farmers make good biodiversity managers? Well, I think one of the things is they know their properties really well. I mean, they're there, they mightn't know the scientific name of all the plants and animals, but they've got a good feeling for what's there. And if they're told what's there, they know even more and they're even keener. They're present 24/7. Farmers are incredibly practical and innovative. They are great at thinking up solutions to problems that someone like me would never think of. They've got very low overhead costs. They don't have overheads in the way that a government agency, for example, does. And most farmers, and there are some obvious exceptions, and most farmers do have a strong environmental commitment. And I've just recently produced a book on biodiversity in farming areas, I'm going to show you in a second, but we worked up that as sort of a vision for biodiversity in rural New Zealand. I think if we're to sustain biodiversity in rural areas, we need to sustain both farming and biodiversity, because as I said before, you can't be green if you're in the red. We want to have a landscape in which native biodiversity prospers, it's valued by rural communities, and where management expertise and efforts of farmers in sustaining native biodiversity is valued by all of society. And that's a really important point. I'll just come on to the next slide. I think if we're to get good biodiversity management in farmland, we need to develop trust and respect between the different parties that are involved, and it has been a little bit shaky at times, shall we say, over the years. We need a comprehensive package of biodiversity incentives, and I think separate to existing conservation funding, but we also need greatly enhanced information sharing. And this term biodiversity ambassador has been used by 1 or 2 district councils, but the idea that we have people who are available in rural communities, maybe situated within district councils, that can work alongside farmers and give farmers the information so they know what they've got, they can tell them where the funding sources are, they can provide the feedback. Not regulatory people, not people who carry a stick and say, oh no, you broke your resource consent. People who are independent of that, who can be real ambassadors for biodiversity. And I think if we were to invest new money in conservation, funding biodiversity ambassadors throughout rural New Zealand would be a really good example. And I think it's something that's really, really lacking. And again, the top left-hand photograph is, I think, one of our preeminent biodiversity ambassadors is Brian Malloy again here, talking to a group of Banks Peninsula farmers in the top left. But the other photographs from Australia and New Zealand of groups where they are talking about biodiversity issues in rural environments with farmers. The bottom left-hand example is one of the catchment board people in Australia who is working with a farmer, talking to him about how he manages his native grasslands. And there are many other examples that are out there, but it's something that I think we have let go in New Zealand, and I think it's something that we could really develop and do a lot better at, getting information out there, helping farmers, working with farmers to get good positive outcomes. So I just mentioned my book. We've just published a book earlier this year talking about these issues, nature and farming, of a colleague of mine in Australia. It's in New Zealand, Australia. It's got many examples. If you're interested in a copy, I've got 5 here. That's all I've got with me. They're $50 each, or we go to CSRO Publishing and it'll cost you nearly $80 there, I think, they're the publisher. But yeah, I just mentioned that if you want to read more about some of these ideas around farming and nature. So I've got a minute left, so I just want to do some conclusions here now and just sort of make some general points. New Zealand has got an amazing, unique biodiversity, but it is in a very perilous state. It continues to decline. Many extinctions occurred in the past. They're really obvious. We hear about them a lot, but they're still occurring and they're going to occur in the future. Extinctions aren't a historical thing. They're an ongoing thing in New Zealand, unfortunately. And we know from the efforts of lots of different people, forest and bird, different groups have highlighted that there is not enough funding out there for conservation at the moment. It just isn't enough to address what's going on. So I'm suggesting that we're not going to get a sudden doubling of conservation funding. It's not going to happen from government in the foreseeable future. So I think we need to think about some other approaches to complement that existing government money. I think we need to be a bit broader and a bit more inclusive, and we need to involve all the stakeholders in how we do that. And I think we need to work with some of these groups that might be regarded as negative for biodiversity, because I think they can actually offer us a lot. Miners, energy generators, tourism operators, infrastructure people, farmers. And I think we can find win-win outcomes. We need to move beyond old mindsets. We need to think about, as I said before, nature and people. Conservation or protection and development. We need to find new ways to go forward. And I think if we do that, I personally feel quite optimistic about the future. But if we don't make these changes, I personally think that we will be facing a lot more extinctions in the future. So thank you very much.